Hello, welcome you all. My name is Suman from Uplatz. So the module we are discussing about statistics and EDA along with Python, sorry, along with our language. I'll just go to notebook and I'll explain. Okay. So in this perspective, what we understood, what we covered. Now I have been covered descriptive statistics along with our language, like before our language, we have to understand the basics of statistics, like what kind of variables are there, like is that numerical or categorical. What is a numerical? Is that nominal or ordinal? What is a categorical? Is that a variable might be a ratio scale or interval scale. Okay, these are the things we understand clearly in the previous session. I'll just move forward. Not only that thing, we can make sure to understand, center tendency, like mean, median, mode. And in the meanwhile, we have to understand the basis of variability. Like, we have to understand how one variable or couple of variables to be variate with the mean. Change shape and shape of the distribution. And we understand shape of the distribution, measurement of the shapes. Like it might be left tail, right tail, or normal distribution. Okay. So these are the things we understood in along with the data set size, along with the data sets in the table. So these are we covered, but what other perspective we have to look at. Like we will just move forward, along with not only just descriptive statistics, which explains data, but along with we have to look forward over the inferential, right? Inferential in the sense like sampling is there. Sir, sampling is there, but how do we make sampling? And so many packages are there. Okay, so many packages are there that we can able to understand. But in perspective of the data set, we have to understand, what kind of things are going forward in with the related with something like statistics. We can say simple inference statistics will explain not only just for data. Okay, that's fine. We have to get the data and we have to input the data and we have to get the better insights. But along with data, you have to understand a couple of. Right? So that's where comes into information statistics, picture. But how do we make sure to provide that in our language? That's important thing. Companies are looking forward. Now, in that context, I have to know first is sampling. Second thing is sampling distribution. Third thing is estimation. Estimation. There are two concepts. Point estimation is there, and interval estimation is also there. Either point or interval. Confusing. And along with point and interval estimation, we do have hypothesis testing is there. Various kind of tests are there, but how to we make sure to provide it. So this is nothing but information, but we'll make sure to understand, same way, like however we have been gone early, the similar concept, we have to go on with the information statistics, and we have to make sure to understand. Now further, I'll just give it a simple studio. Make sure to understand. have been shared the screen here our studio. I just make sure to control it to clear the data, early data, in the sense like temporary data. Okay. And here I just want to provide better information, like we have to understand what is things we have to move forward. In the perspective of information, first thing we have to understand libraries, packages. So for this, I have to take it a library called dplayer. So in that case, I just provide dplayer library. Just dp dpl player, or just copy paste, or maybe can scroll the tab key and we'll get it. So first thing, we imported the package. Second thing, I have to know, something like population in that census. You have to understand sample mean. Already we understood sample mean and sample estimation. But what is estimation? Like I explain estimation is another word. One is point estimation. For example, we can take a simple general example. What is the average age of the Indian? So Indian is not a one person, right? Indian is 140 crores of the people. But what is the average? Just point, just one point, and we are estimating. That's what point estimation. But what is interval estimation? How it is different with the point estimation? See, point estimation is not a single point you are focusing, but is that true or wrong or right or something? Change. But when you go to interval estimation, it's more than that one. For example, I would say, point estimation, I could say 29 years. 29 years is the average age of the person. Of the person in the sense like, maybe male or female, but overall, across total. But what is interval estimation? It's not the 29, but I would say 20 to 30 or 35. 20 to 35 in the sense like, 21, 22, 25, 29 or 30, but ultimately it's an interval. It's not like just like, or not like point, but we are providing data according to, interval, but not, single point. But when it comes to point estimation, it's nothing but point estimation only. Like, we can say single point. Single point in the sense like, single data. You can say either way, this or that way. But we can able to say single point or single data. That's what point estimation. But when we go move forward, it might be interval estimation. So these are the main things, which can focus on the like inferential statistics. But how do we get it? And what sort of things we can provide and what sort of things we can get in? So for this, what I will do, I'll just take in a simple way to make sure to understand. First set.cd is there, this value, and you can click simply 1, 2, 3. Anything, any number, that's up to you. But the same number will be explained rest of the data. Set.t seed post pointer, and here I'll just create a population. Population. I just provide simply alt Alt left arrow, right? Alt left arrow, and I just want to create a simple data frame. We know it a data frame. This value, and here I have to provide simply. Okay, let me make take into the income. Income is one example, and in this case, I want to provide R now. Normally solution. I just want to take some data. So in this data, I just want to take first population. For example, 10,000 something. Okay, I just want to take 10,000. But here I have to provide mean, right? So in this mean value, I just want to give it some mean value, something like you can give it any mean. That's up to you. But I'll just give it mean something like 5,000 or 3,000. Mean equal to 50,000, comma. And here I have to provide a standard deviation. So that's equal to like 15,000 or something. You can take it. 50,000. So this is my data frame related to what? Population. Right? In the population, I have to provide even more further. I have to take a sample, and underscore data, and I have to provide sample data with related to what? There is a function called sample in this value from the deploy, and which can take sample in rows from a table. You can see here clearly explains sample in rows from the table. I'll just click on it here, and here I have to take population, whatever above population, this value along with, and I'll just create some 100 values. 100 simple. All right. So I'm taking overall population of the top of the population. In that population, I'm taking 100 such values, sample values. So that's what sample, simple, right? But in the case of calculation, what I will do it sample mean. I just want to provide simply shift enter, and the sample is there, and okay, I just provide mean and alt arrow mark. And here I have to provide mean value. Mean of what? Mean of sample data, right? Mean of this sample data along with dollar symbol and income. I'm taking only income. Okay, income. And here I just want to sample is the sample underscore SD. Sorry, I'll take SD alt, and this value may be SD, but I will take sample underscore, sorry, underscore data along with same way I can take income. Simple. Correct. So first thing I have taken a population which contains data frame which contains income, which contains which has mean and standard deviation. Whereas second time I have taken sample data from the overall population. Third time I have taken sample mean, sample SD. Okay. Now I just want to display these values. I just copy here. Sorry. I just copy paste. Now you can see it's clearly indicate this value. I just load necessary libraries and I just want to generate and just want to display. And here I can see sample mean is this value. Sample SD is nothing but 16,000 change and 49,000 change is the sample mean. Okay, it's clear, right? Now, okay, this is fine. You can able to understand from the history of the data. Now, what is estimation? I just want to provide simply point estimation. Point estimation, right? Estimation. So in this context, what I have to provide it? Point estimation is one which I told simply, clearly, simple, something like I will take in this way point underscore estimate, whatever you can take any variable name. Point estimate is here. Indicate what? Sample mean, my sample mean. Sample underscore mean is there. No? This is a point estimation. Because that is the only one value which explain point estimation. Now question comes to here is what is point estimation? Sorry. Point estimate, right? And sample underscore mean this value and shift enter point underscore estimate this value. So this is a value which comes into point estimation. Simple. A single value which point estimation. Now then comes into interval estimation. Like what is interval? And we have to understand. So we have to create confidence interval for the population mean. We have to simply create confidence interval from the population. Now here I want to tell error simple underscore margin error underscore margin. I just want to give it simply left arrow and here I have to provide q norm. Okay, and here 95% in the sense like 97%. I just want to 0.975. So this is what interval I'm giving something like for example where you reach somewhere I have to go to some location to some location, A location to B, but in that location A to B, okay, fine, that's good, but how much you are confident, how much you are confident in the sense like how you can able to tell other person confidentially percentage wise. In that cases I would say okay, 95%, 97% I can provide, right? So in that context we have to take it this value and just multiply, and here I have to take simply sample SD sample underscore SD this value, okay, by square root of what? Square root of number of rows according to what? Sample data. Sample underscore data. This value. So this is what error margin. In that cases, we can say, it's nothing but we are calculating 95% confidence interval for the sample mean. Okay. Now question comes to here is what is confidence interval? So for that, I'll just give it a confidence. Okay, that's fine. And it might be something like font something, and I just want to take here interval interval, this confidence interval, and I have to take simply C because we know it as C for list, and I just want to say take sample mean here. Sample mean is value post and minus this error margin so this value or copy paste it either way. Copy paste it. Now sample mean is there. Okay, that's fine. Sample underscore mean is there. This value plus error margin this value, right? So in these cases, we can see, something like, we are getting confidentially data, and I want to display this confidence interval as 2. So for this, I just want to provide here shift enter confidence interval. So what do we understand? Here, a person has been created simply 97% of confidence interval towards the population along with sample data. Okay. Now we are looking fine. This is okay. Now we are getting data and we are looking for confidence interval. I just want to click on here and we got it this not like 1 point. So early you can see 49,907 we got. That's fine. Single point. But right now we didn't get 49, but we got 46,000 change plus 2, 53,000 change. So what we would say, what we can able to understand, it's a confidence. Like, person have been, for example, you can take simple example, general example. A person is a student is there and his parent is there. He's telling 1 point, my son has to be get 78 marks out of 100. That's what point is to be. Because we are telling only 78, nothing else. But other person can able to tell not only 78, 70 to 85. 70 to 85 is different, 78 is different. 78 is nothing but a person is telling only 78. 77, 76, that might be wrong. Okay, he's telling just point, single point. But other person can tell 70 to 85. Maybe 72, that's also right. 75, that's also right. 84, that's also right. But across total, we can say it's a confidence interval. That's a range from some number to some other number. So this is about confidence interval. Okay, I can able to hope so you can able to understand in a similar perspective. So that's about inference statistics, and in the meanwhile we can able to tell confidence interval. But across total, okay, we understood that's fine. But if you want to test something, for example, if you want to test that average income in Hyderabad or some location, is that significant or different from the other number? Let's take some college, some XYZ college. They are telling if you study in my school or my college or my institution, you are getting 100 out of 100, you are getting 95. That's good. You can assume that's good. But how can you believe that's good? How can you assume that good? Or how can we say, is that right or wrong? Maybe he might be say wrong because he want students, and he want colleges, and he want to his own business, right? But in that perspective, in that context, what we have to provide as per our language, as per statistical language. So we have to go for the hypothesis testing. Okay, hypothesis testing. Maybe he might say right at that time, but it might be wrong. Okay. In that cases, we have to know whether it's right or wrong. Sometimes it might be wrong. Right. I can say. Sometimes it might be wrong. Right. That's true. But some context it might be wrong. Right. Maybe they are telling lies. We don't know. We don't know. Because I can't go to each and every student, right? Whatever they have students early, whatever they have couple of students and a couple of so many things we do know, but ultimately have to know whether it is right or wrong. So that's where comes into hypothesis testing. Okay, that's where comes into some concept called hypothesis testing or or testing. Either way. But how do we know it? How do we know it? In that cases, I have to look forward. Firstly, I'll just provide here simply hypothesis testing this main thing strap, and here I have to perform some kind of test. Okay. So in this context, I'll just provide t underscore test simply. T test is there and t test. Okay, t test. Okay. And there is a method called t dot test is there. You can see that's a function which providing from the R language t dot test. And here I have to take sample data because we are working on the sample data along with what? Income, right? Along with income. But here I have to provide mu. So mu equal to something like, I'll just provide 45,000, something. Whatever is there now, 45,000 I'm providing. Then it can understand. Okay, 45,000 mean what is the t test it will provide. So that's what t test, and it can able to provide not only value, it also provide cross total t test. And we got it t test. This is called t test, but it's working on the income data, which is come from the sample, but not a population. But a population is there. We got some p value along with what? Along with we got t value, we got df, we got p value, along with 95% confidence interval also we got it, right? So this is what t test in sense of uh, in sense of what? Confidence in sense of inference statistics, right? So this is one perspective, we can say one aspect, but other aspect is also there, analysis of variance. I know. So if you want to compare, like okay, this is fine, we cannot able to understand, it's clear our student is giving, but what is ANOVA? What is why they are calling ANOVA? Why we can make sure to know it ANOVA? If you want to compare the average income across different districts, not only Hyderabad. Hyderabad is there one area, but Bangalore is there, Chennai is there, and Pune is there. But a person want to compare these cities like Hyderabad, Bangalore, Chennai, or maybe other cities. But in that cases, we do have ANOVA because the person is comparing with the different various cities. So in that cases, we'll just now go forward for the single value, but we will move forward for the different cities, right? You're able to understand. So that is what ANOVA. ANOVA is nothing but a person is comparing the various cities with relevant with different data. Maybe same data, maybe it might be, but different. You can consider, cities are different. Data might be same or small changes. That's okay. But as cities are different, because Hyderabad is different, Bangalore, we know it already. like compare with Bangalore, maybe Hyderabad might be low or maybe high. Compare with Bangalore, Chennai might be slow or maybe Chennai might be better. But in that context, how do we know? So that's where comes into ANOVA. Okay, analysis of variance. We are calculating with various cities, but analysis of various cities we are looking forward that data. So that's what ANOVA. Now further, how do we know it? How do we know it and how do we calculate? So further, what I will use is to clear the console here. Set is there, city is there. I just want to give it some number. But again, a number. I just want to take 4, 5, 6. Okay, and shift tab. And in this context, I want to create a simple data so that you can make sure to understand data is there. Data dot frame is there. Simple. And in this data dot frame, we do have something like, I just want to repeat. Repeat is nothing but repeated. C, I want to take C vector. In this vector, I want to take 3 areas. You might take anything, but I'll just take it in my context. Hyderabad, Hyderabad, and Bangalore, something like Chennai. Okay. So I'm creating simple data frame with the related with Hyderabad, Bangalore, and Chennai, but I have to provide some each. Each is what? So each is nothing but you are going with the calculation with repeated values, right? With repeated values, this is okay, fine. Till here C is there, clear, till here, and repeat is there, no? Here, till repeat. So here I want to provide something, a value which indicates each is equal to 100. Okay, I'll provide one more value, but I'll just make sure to understand here. Simply, this value indicates each equal to each is equal to something like 100. Simple. Okay, each is equal to 100. Okay, that's fine. But in this context, I want to provide more such values. Such values are like this. Like income, you can take shift tab, and I can provide income. Income equal what? I'll just take C, and I'll just provide R now. But R now, and I just provide simple value, right? So here it might be 100, right? And I just want to provide a mean, and this mean equal to something like 50,000 something. You can take any number, but I'll just take 50,000. And here I just want to provide SD. SD equal to something like 15,000. 15,000. Sorry, 1,000. Right. So this is one income. But what happened, just to go to forward. I just copy paste simply. Just copy. Okay. And here you can paste it. Paste it, paste it. Paste it here. And this value is a comma separated because we have to provide comma separated here, and comma separated here, and comma separated here. Right? This value. Now you can see it's clearly indicate C values, but I'm taking 100, but I just want to change it here, small values. For example, you can change this to 2,000, and you can change it to something like anything 48 something. And here I want to change SD to 14 something, and I want to change these values to something like 60. Okay. Now, okay, we understood, and these are the 3 values we are getting. That's okay, fine. But how do we know it ANOVA? And how do we compare these three cities? Right? So for this, for that, we do have option is there. Here we have like I'll just go to forward here. Okay, it's fine. It's fine. Here is one fine. One parenthesis closed. This one parenthesis. This one parenthesis. Okay, that's fine. I'm just creating data. Okay. Unexpected symbol in data. Okay. That's fine. That that just make sure to revert back and data I just want to provide. Now you can see. Okay. We got it the data related with the three different cities. Bangalore is there, Chennai is there, Hyderabad is there, and we got the data with not only just the cities, but we are getting data from income, including with income. Okay. Now, how do I find it? Now, how do I find it another? So for that, I'll just want to provide simply here. I'll just go to ANOVA simply. And in these cases, I'll just provide simply ANOVA result, something like result, or you can take anything, some variable. And here I have to provide AOV. AOV. So in this AOV, I have to provide first numerical variable that is called income. Income first and tilde operator. And in this tilde operator, after tilde operator, I have to provide city because that is the city which contains values. So I have to provide simply city, right? City is there, but I have to explain what is this data. So I have to provide data equal to simply data. So this is what I know a result, and I have to provide summary of the ANOVA result. I'll just go to copy paste simply, copy paste, and I'll just go to move forward. Shift tab, summary. Sorry, not summary. Just take summary and paste it, and we'll get it. So this is what I know. Okay, we understood. But what we understood is important. Like we are getting from the three different cities, and we can able to understand clearly with related with the three different cities, like not only Hyderabad, but we are getting data from multiple different areas. Okay. In that context, we can see in the simple way, we can able to understand, we are looking the data forward for the not only just for one area, one custom data, but we are looking forward for the different areas and different cities. But we are looking for the not only point estimate, but we are looking forward for the different cities, different areas. Okay. So that's what ANOVA. Okay. Now we can able to understand clearly, and we can able to understand in a clear way. We are looking forward for the one value which is related to a simple point, but we are looking forward the multiple variables for the multiple different categorical data. Yes.